Alright, so this will be an introduction to my third video series, which will be on ordinary differential equations, and eventually, once I get around to learning it, partial differential equations I'll probably throw in the mix towards the end. But basically, differential equations are, I think it's probably one of the most useful branches of math there is, because there are so many applications to really everyday problems like physics, engineering, economics, chemistry, biology, pretty much any science you can think of. I'm sure there's a very important differential equation used in that science, and they're also interesting to study in their own right because they have some interesting properties. And basically, differential equations really you have some function and its derivatives. Basically, I like to think of differential equations as really just algebra with derivatives. It's kind of really what you're doing for the most part. Now, it's not quite as simple as that because there are a lot of different techniques. It's not like algebra where you kind of like do the same like four or five techniques that you do for every single problem. There are actually a lot of different techniques for differential equations, and you have to kind of work them enough to know which technique you should be using to solve it. Down here I have a really simple example, and I'll show you really how to kind of work a very basic one. But much later, you'll see that differential equations, there are some of them which you actually can't solve analytically, which means you're not going to be able to get like some function y and say this is the solution to the differential equation, some function y. In some cases, you have to do numerical methods, which means that you have to use like different techniques that are kind of like more computer based to solve the differential equation because there's not a way to solve it analytically. And so basically, I'll just show some kind of an overview of what differential equation is all about. So you have, let's just take Newton's second law, force equals mass times acceleration. Acceleration is equal to the derivative of the velocity with respect to time, and of course velocity is the time derivative of position. And so you can actually rewrite this in differential equation form. You can have force times the force as a function of time, position, and the derivative position of velocity is equal to the mass times the second derivative position with respect to time, second time derivative. Basically, there's a lot of stuff like that. You can rewrite a lot of functions in terms of the derivatives, and you can actually use that to solve a lot of kind of problems. And with physics, that's kind of like they're used everywhere in physics. But of course, in higher physics, it's more partial differential equations, which are where you have functions of more than one variable, and you have to take into account even more things. But anyways, so here I've drawn what's called a slope field, and basically slope fields are where you have this kind of like, you can think of it as at each let's say we have at each point in your when you evaluate the function, what is the slope? It's kind of like when we have like in calculus, like when we have like graph like this, we have like some tangent line. That tangent line is different. This tangent line is different. Basically, this is kind of what the slope field is. Kind of like graphing a bunch of tangent lines. And they're also called direction fields. And this is the one for sine of x. Pretty simple. When you kind of see like at first the slope is nothing, then increases, then it starts to decrease again. And that's kind of like that's really what the direction field tells us about differential equations. And later on, I'll talk about how you can tell certain properties of a differential equation based on the slope field. Not necessarily solving it, just like some certain properties. And basically, so I'll just work simple ones. So basically, let's just take our function, y equals sine of x again, and we want to know if that's the solution of this differential equation. And also, before I even go further, there are a couple ways you can write this. I wrote y double prime because I think it's more compact and faster to write it that way. But you can also have written it as derivative, like this. You could have written it like this, and both of these are equivalent ways of writing the exact same differential equation. So basically, let's find out, is this true? Is it equal to 0? Is y double prime plus y equal to 0? Well, we can take the derivative of sine, which is cosine of x, and then so you can take the second derivative of cosine, just negative sine of x. And you can see that so the second derivative is equal to negative sine x, and y is just sine of x. And we can see that equals 0. So this function is indeed a solution to this differential equation. Now, if we had something like y is equal to 4x, and so let's just say y prime is equal to 4, and then y double prime is equal to 0. Derivative of constant 0, and then so that would just be you can see that it's not equal. We'll just plug it in. So we have 0 plus 4 obviously does not equal 0. So y equals 4x is not a solution to that differential equation. And so that's kind of like what we're going to be doing. But of course, sometimes obviously a lot more complicated than that. This is just a very simple example. That's kind of like, you know, the idea of what differential equation is all about. You know, you have a function a function and its unknown derivatives. That was weird. Raise the x. Anyway, so you have a function and you have some function and its derivatives, and you basically want to solve for sometimes, you know, some constants. Sometimes, you know, you want to know you know, how a function behaves at certain points. You know, I'll get into all that much later. Basically, this is kind of like an introduction to what differential equations is all about, and I'll probably be doing more of my Calc 3 and Set 3 playlist. I'll be periodically doing one on differential equations. But basically, I should say updating this playlist. But anyway, so that's all for this video, and I'll see you guys, I guess, in my next video.